Hello class. Sorry I am not here today. We have a sick daughter at home with a fever, so it's my turn. So if you could just have a sheet of paper out, we're going to do the 4-4 notes day 2. So we've learned 4-1 through 4-4 day 1. This will be the last section before you have your quiz. Your quiz is on Thursday. Tomorrow I will be at school, so we'll go through anything that you don't understand from the notes on this video. Tomorrow we'll also do the 4-5 notes, but the 4-5 notes will not be on your quiz. The quiz, remember, will be all non-calculator. Okay, so let's get to, we started talking about logs on Friday. We're going to do graphing logs a little bit today. We already graphed exponential functions, and now we're going to be graphing logarithmic functions. And we'll kind of see what those look like. All right, so if you remember when we did exponential functions, which are the inverses of log functions, we had something like y equals 2 to the x. All right. If we have something like y equals 2 to the x, remember you always have, 0, comma 1, because 2 to the 0 obviously is 1. You have 1 comma a, so 1 comma 2, and then you would have like negative 1 comma 1/2 because it's the reciprocal. Negative 1 comma 1/2, and so the graph looks something like this. All right, now since they are inverses, all right, they're going to be symmetric with respect to that line y equals x, so I'm going to draw that line in. Okay, and so this, written in log form, would be log base 2 of x equals y. Okay, and so what we're going to do is we're going to graph it. Now remember, these are inverses. And when they're inverses, remember that the domain and the range basically swap. So if you have the equation y equals 2 to the x, you're going to have the following points. I already kind of labeled them on the graph. All right, so you've got negative 1 comma 1/2, you've got 0, 1, you've got 1, 2. You could even put 2, 4 on there if you want. So those are the points on y equals 2 to the x. If you do y equals log base 2 of x, remember that since they're inverses, the domain and range will be swapped. So basically all you're going to do is just switch these points around. So instead of negative 1, 1/2, you'll have 1/2 negative 1, you'll have 1, 0, you'll have 2, 1, and you'll have 4, 2. All right? And so when we graph those, we're going to end up with, let's see, 1/2 negative 1, we've got 2, 1, all right, and then we've got 4, 2, which is over here. So the graph is going to look something like this. All right, so this is y equals log base 2 of x, and this is the exponential y equals 2 to the x. All right, so that's kind of the difference between the two graphs, and they're just basically symmetric with respect to the line y equals x. All right, now when you have a log, remember that the base, is going to be something other than 1, and it has to be positive. There are going to be cases where a is greater than 1, and then we're going to talk about when a, the base of your log, is between 0 and 1, so when it's a fraction. And we did the same thing when we talked about exponential functions. All right, if you remember with exponential functions, we had, the points like 0 comma 1, we had 1 comma a, we had negative 1 comma 1 over a. That was in the exponential functions. And so now when it has a log, it's just going to be the reverse. So instead of 0 comma 1, you're always going to have 1 comma 0. All right, you're going to have a comma 1, whatever a happens to be. All right, a comma 1. It's something greater than 1, so I know it has to be the right of 1 on the x-axis. And then we're going to have negative 1, 1 over a. I'm sorry, 1 over a, negative 1. All right, 1 over a, we know it's between 0 and 1, and it's going to be down here at negative 1. All right, so that's going to be kind of our points when a is greater than 1. Let me label these points here for you. So 1 over a comma negative 1. Now, if a is a fraction, it's something between 0 and 1. It's going to switch things out a little bit. All right. What will happen is we're still going to have this point 1 comma 0. All right. So 1 comma 0 isn't really going away, but then the other ones kind of change. Now keep in mind that a is a fraction. So we'll still have the point a comma 1, but because a is between 0 and 1, it's going to land somewhere in between 0 and 1 on the x-axis, and it'll be up here at 1. So a comma 1 is still on the graph, it's just to the left of 1 comma 0 now. And then the other point, 1 over a negative 1, 1 over a negative 1 will be to the right of 1. And hopefully that makes sense, because if you have a fraction like 1/2 and you do the reciprocal, it's going to end up being somewhere to the right of 1 on the x-axis. So my graph kind of looks something like this. Okay, and the vertical asymptote, by the way, is going to be here at 0 for both of these graphs. Because remember that our base can't be 0, and it has to be positive. Okay, and it can't be 1. So those are all the different things. All right, so the properties of log functions. And there's going to be a whole list of them. All right. Properties. All right, so the domain is going to go from 0 to infinity. All right, and the range can be anything, negative infinity to positive infinity. All right. 2, the x-intercept is going to be at 1, 0. The y-intercept, because of that vertical asymptote, there isn't any. All right. 3rd, x equals 0 is going to be the vertical asymptote. All right. In other words, the y-axis. All right. It's always going to be decreasing if it's the graph up on the right, where a is between 0 and 1. And it will always be always increasing if it's like the graph up on the left. So if a is greater than 1. All right, and then it's going to contain those points that I mentioned earlier. It's going to contain 1, 0, a comma 1, and 1 over a negative 1, the reverse of our exponential functions. All right, natural logs, you might have seen those a little bit in the homework from Friday. Natural logs, or ln, have a base of e, so you'll see that from time to time. So y equals natural log of x, that's the same thing as e to the y equals x. We don't usually write a base of e, it's just kind of assumed. All right, so we're going to look at a graph. So example 1, we're going to graph f of x equals the natural log of x plus 2. All right, we're going to graph it, we'll find the domain and range, and we'll find the vertical asymptote as well. So the transformations, all right, we've done this with exponential functions, now we get to do it with logs and natural logs. All right, so the transformations, the first thing that's happening is that negative. All right, that negative means that we're going to reflect with respect to the x-axis. All right, and then the other thing that's happening, that plus 2, means that we are shifting to the left 2. All right, and so what's going to happen is if you graph the natural log of x, all right, the natural log of x is going to be just like your basic log function where a is greater than 1, because e is greater than 1. It's going to have this general shape, all right, where you have your vertical asymptote here at x equals 0. All right, so that's the natural log of x. And then what's happening is this thing is not only reflecting over the x-axis, all right, so your new point is going to land here at negative 1, 0. All right, sorry, it's not going to land at negative 1, 0. What's going to happen is it's going to reflect over the x-axis, so this point's staying the same, but the rest of the graph is kind of flipping. And then we're going left 2, so this point is going to move 1, 2 spaces to the left. So we're going to end up here at negative 1, 0. All right, and so the graph is going to end up looking like this. All right, and the vertical asymptote is also shifting to the left too. So our new vertical asymptote is going to be here at x equals -2. All right, so I probably should do this in a different color so you can see it better. So the natural log of x, we can do that in red maybe. That'll be easier to see. So this is the original graph with this vertical asymptote. And now our new graph is the one in blue. All right, it's reflecting over the x-axis and it's shifting to the left too. So that's going to be your general new shape for your graph. All right, as far as the domain goes, for this thing, we know that it can't equal -1 or anything to the left of that. So it's going to go from -1 to infinity. The range can be anything. All right, the y values aren't restricted at all. And the vertical asymptote, we drew that in, it's at x equals -1. All right, so we have that. Let's see. Something that I mentioned last week, common logs. All right, the ones like on your calculator, they have a base of 10. So if you have something like y equals log of 4, that's going to be an exponent form, 10 to the y equals 4. All right, just like natural logs, we don't write the base out. It's just kind of assumed that it has a base of 10. Okay, example 2 is one more graph, and then we'll get into just some solving. That's a lot quicker. Okay, so for example 2, we've got f of x equals 3 log base of 10 quantity x minus 1. And we're going to find the domain and range, and we're also going to find the vertical asymptote. All right, so first off, we're going to list the transformations. So we got a couple things going on here. First thing is going to be the 3. All right, the 3 is going to be a vertical stretch. So that's going to change your y values by a factor of 3. And then the -1, that means that we're going to shift to the right 1. Okay, now again, this is got a base of 10, so this is going to be your typical log function where a is greater than 1. All right, and we'll graph that in just a second. Let's look at the table of values for these things. Okay, if this was just a regular y equals log x, all right, what you would have is if you plugged in 1/2 for x, your y value would be whatever the log of 1/2 is. Not a very nice number. If you plugged in 1, if you plug in 1, 10 to the what is 1, 10 to the 0 is 1, so you get 0. If you plug in 2, you'll get the log of 2, whatever yucky number that is. All right, now this thing, what happens is we have 3 log quantity x minus 1. What's going to happen is the 3 is going to affect your y's, so you're going to multiply the y's by 3. All right, and the x minus 1, what's going to happen is you're going to basically be going to the right one, which means that you're going to add 1 to the x's. All right, so we can create our new table. And so add 1 to the x's, we're going to have 1.5 or 1.5. If we multiply the y's by 3, you're going to get 3 log 1/2. All right, if you add 1 to that, you'll get 2. Add 1 to that, you get 3. And then multiply the y values by 3, you get 0 for that one, and this is 3 log 2. All right, now obviously you wouldn't really be able to know what those are without a calculator, so this is probably not going to be super essential for the quiz since the quiz is non-calculator. But when you graph it, essentially what's going to happen is you have your x-intercept here at 2, 0. It's going to follow that general form, so you might have kind of like a sketch, maybe more so on your quiz than knowing what those values are. But it's going to look like this. The vertical asymptote normally is at x equals 0. It's shifting to the right one. So our vertical asymptote will now be at x equals 1. All right, so the domain, it's everything to the right of 1, so 1 to infinity. All right, our range can be anything. All right, negative infinity to positive infinity. And the vertical asymptote is going to be x equals 1. Okay, so that's kind of the graphing part. What we're going to do is do some solving some log functions. So I only have like 4 more to go that are super quick. They don't involve graphs, so check out the next video to see that part. Thanks.